it's kind of nearing midterm season, we decided to do something fun, something that's not so involved. And one of the ideas that we came up with is to showcase deepfakes and AI art as a workshop. So I guess because we targeted this workshop at anyone, doesn't matter if you're coming from a statistics or computer science background or even commerce. I guess I just first have to go a little bit into the background of things. So what is a deepfake? Deepfake is a combination of words deep learning and fake. It describes the synthetic generation of media or modification of image, video, and audio using machine learning techniques. So early versions of this deepfake algorithms have actually existed for the purpose of movie post-processing as early as the 1990s. But the term deepfake as we know it did not reach mainstream attention until late 2010s, when the term fake news suddenly became such a huge trending topic. And if you need a visual understanding of what deepfake is, I'm sure you've seen this at least a couple of times in your life since, I guess, Trump presidency. A little bit more about how a deepfake works. So the prominent algorithm behind allowing deepfakes to work is called generative adversarial networks. So just on a high level, we need to understand that it belongs to a class of algorithms in machine learning called deep learning. For those that do not have a background in machine learning, I guess we kind of need to cover a bit about what actually is deep learning. So at the broadest level, artificial intelligence encompasses any program that can act, sense, reason, act, and adapt. And within the field of artificial intelligence, there's a subset of algorithms called machine learning. Those algorithms allow machines to imitate intelligent human behavior. So essentially, a human tells a machine how it should be behaving, and over time, the machine should be able to perfectly replicate the human behavior. That's the gist of machine learning. And within the domain of machine learning, even deeper is what we call deep learning. At a very high level, again, it's just complex algorithms inspired by the anatomy of the human brain that can learn pretty much anything you throw at it if you give it enough data. Well, I guess the TLDR of that summary is deep learning is like a machine brain. If you feed it enough information, it's going to pick out the nuances within the data that you're feeding it to make a judgment, I would say. So like I said before, the GAN architecture is the main driving force behind allowing deepfakes to excel. So if I were to break it down once again at a very high level, GAN architecture contains two main components. Each of these color components, you can think of it as a brain. So this guy receives input real images and fake images. His only job is to tell if the image that he has received is real or fake. The second half of the GAN architecture is called the generator. We can think of this as a brain that takes the input of random noise. His only job is to generate a fake image. So when one iteration of this algorithm is ran, either the discriminator is able to call out that the generator has made a fake image, or the generator was able to fool the discriminator with the fake image that is created. So it's a zero-sum game. Either he wins or he wins. Whenever the winner of the two algorithms wins, some information is passed to the loser, so the loser knows how to make a better fake image next time. So if the discriminator could tell that it was a fake image, some information gets passed back here that says, hey, this is how you make a better fake image next time. But if the opposite is true, if the generator managed to fool the discriminator, then the generator tells the discriminator, hey, this is where you got wrong on the fake image. And then through hundreds of thousands of iterations, we eventually reach a computational algorithm that that is almost able to fool humans. So this thing is so good at generating fake images that even the discriminator wouldn't be able to tell. So I guess to answer one of your burning questions, why are DSC showcasing deepfakes? It's almost exam week. We usually hold something fun after we wrap up around the time where all the first assignments are due. So usually we have something like board game nights, but we thought we'd still like to have something fun, but there's not a lot we can do online. So we decided to do a deepfake workshop. Yeah, we think data science is more than just running algorithms on massive data sets. So, and we understand that the term deepfake is a highly stigmatized topic by now. It's such a shame that the stigma surrounding it takes away from the recognition deserved by the brilliant minds that designed the algorithm. I guess to sum it up in one sentence, we want to look past the stigma of the word deepfake and allow our members to gain appreciation for lesser known machine learning algorithms. And I'm not sure if you guys saw the preview that we posted on Facebook. The stuff that we're making today can be pretty goofy, and I'm sure it will be able to crack you up. So by the end of this workshop, what should you have achieved? You should be able to describe the tech behind deepfakes to anyone. So most people's knowledge of deepfakes is just what they heard on the news. Oh, fake news, things like that. You should be able to create, again, synthetic media of yourself and friends. So that's where these notebooks come in. We've prepared some examples that we sourced from the internet that's going to help you create some deepfakes yourself. You should be equipped with ideas to kick off your own GAN project. So we'll be sending out some ideas to, I guess, showcase how some people have incorporated GAN into their own projects. If you do something that's related to this, you put it on GitHub. By the time it comes for you to be looking for a job, it could be something that impresses your employers, shows that you have a great interest in data science. And the last thing we equipped, we found a bunch of further resources for you guys to look deeper into GAN if the workshop sparked your interest this time around. So I realized a couple of more people have joined the workshop. So I'm going to paste this link in the chat again. What you should do is to download the first notebook. Open the first notebook, hit file, and then go save a copy in your drive. Why this is important, because otherwise everyone would just be executing commands on this shared notebook, and then no one will ever get any actual deep faking done. Yeah, I think I talked a lot about our workshop today. I do want to give more of an introduction on the tech behind deep faking. So I found a really informative video. I think it's going to explain GAN a ton better than I could ever do. So I'm just gonna screen share my screen share and show you guys this video. Are you guys able to hear and see
my
this video?
favorite machine learning algorithms is generative adversarial networks.
Are there sounds?
GAN.
Okay. Cool. So it's just 8 minutes. I'm gonna let it play. I think it's a really concise summary of what generative adversarial networks are about. Shout out if there's any issues, but from what I can see here, everyone's a little quiet. How about
Pits two AI
I'm on
models
max
off
now.
against each other, hence the adversarial part. Now, most machine learning models are used to generate a prediction. So we start with some input training data, and we feed that into our model. Our model then makes a prediction in the form of output. And we can compare the predicted output with the expected output from the training data set. And then based upon that expected output and the actual predicted output, we can figure out how we should update our model to create better outputs. That is an example of supervised learning. A GAN is an example of unsupervised learning. It effectively supervises itself, and it consists of two submodels. So we have a generator submodel and we have a discriminator submodel. Now, the generator's job is to create fake input or fake samples. And the discriminator's job is to take a given sample and figure out if it is a fake sample or if it's a real sample from the domain. And therein lies the adversarial nature of this. We have a generator creating fake samples and sending them to a discriminator. The discriminator is taking a look at a given sample and figuring out, is this a fake sample from the generator, or is this a real sample from the domain set? Now, this sort of scenario is often applied in image generation. There are images all over the internet of generators that have been used to create fake 3D models, fake faces, fake cats, and so forth. So this really works by the generator iterating through a number of different cycles of creating samples, updating its model, and so forth, until it can create a sample that is so convincing that it can fool a discriminator and also fool us humans as well. So let's take an example of how this works with, let's say, a flower. So we are going to train our generator to create really convincing fake flowers. And the way that we start by doing this is we need to, first of all, train our discriminator model to recognize what a picture of a flower looks like. So our domain is lots of pictures of flowers, and we will be feeding this into the discriminator model and telling it to look at all of the attributes that make up those flower images. Take a look at the colors, the shading, the shapes, and so forth. And when our discriminator gets good at recognizing real flowers, then we'll feed in some shapes that are not flowers at all and make sure that it can discriminate those as being not flowers. Now, this whole time, our generator here was frozen. It wasn't doing anything. But when our discriminator gets good enough at recognizing things from our domain, then we apply our generator to start creating fake versions of those things. So our generator is going to take a random input vector, and it is going to use that to create its own fake flower. Now, this fake flower image is sent to the discriminator, and now the discriminator has a decision to make. Is that image of a flower the real thing from the domain, or is it a fake from the generator? Now, the answer is revealed to both the generator and the discriminator. The flower was fake. And based upon that, the generator and discriminator will change their behavior. This is a zero-sum game. There's always a winner and a loser. The winner gets to remain blissfully unchanged. Their model doesn't change at all, whereas the loser has to update their model. So if the discriminator successfully spotted that this flower was a fake image, then the discriminator remains unchanged, but the generator will need to change its model to generate better fakes. Whereas if the reverse is true and the generator is creating something that fooled the discriminator model will need to be updated itself in order to better be able to tell where we have a fake sample coming in, so it's fooled less easily. And that's basically how these things work. And we go through many, many iterations of this until the generator gets so good that the discriminator can no longer pick out its fakes. And there we have built a very successful generator to do whatever it is we wanted it to do. Now, often in terms of images, the generator and the discriminator are implemented as CNNs. These are convolutional neural networks. CNNs are a great way of recognizing patterns in image data and entering into sort of the area of object identification. We have a whole separate video on CNNs, but they're a great way to really implement the generator and discriminator in this scenario. But the whole process of a GAN isn't just to create really good fake flowers or fake cat images for the internet. You can apply it to all sorts of use cases. So take, for example, video frame prediction. If we feed in a particular frame of video from a camera, we can use a GAN to predict what the next frame in the sequence will look like. This is a great way to be able to predict what's going to happen in the immediate future and might be used, for example, in a surveillance system. If we can figure out what is likely to happen next, we can take some action based upon that. There's also other things you can do, like image enhancement. So if we have a kind of a low resolution image, we can use a GAN to create a much higher resolution version of that image by figuring out what each individual pixel is and then creating a higher resolution version of that. And we can even go as far as using this for things that are not related to images at all, like encryption, where we can create a secure encryption algorithm that can be decrypted and encrypted by the sender and receiver, but cannot be easily intercepted. Again, by going through these GAN iterations to create a really good generator. So that's GAN. It's the battle of the bots, where you can take your young, impressionable, and unchanged generator and turn it into a master of forgery. If you have any questions, please drop us a line.
Hey,
All right. I guess that summarizes GAN really well, a lot better than I was able to do here, certainly. I did notice another few people joined us late, so I'm just going to paste this link in the chat again. Everyone in meeting should receive this link. So yeah, you guys joined at just the right time. We just done a bit of an introduction over the first 10 minutes. And right now is actually when we'll be creating our first deepfake. So if I could get you guys to visit the link, open up this first notebook that we have here, and then go to File, Save a Copy in Drive. Why this is important is because otherwise everyone will be executing commands on the shared notebook and then no one will get anything done. So before you run anything, make sure your title here says copy of 1 headshot deepfake. That's how you know you're running it from your university Gmail account. I'll give people a couple seconds to get up to speed. Yeah, so open up that link, open the first notebook, save a copy in Drive, and scroll down until you see this demo for paper section. So just like the instruction says here, if you want to give the demo a try yourself, all you have to do is to press the 2 play buttons in order and wait for the algorithm to finish executing. So after this is done, you should be able to select an image and a video to create your first deepfake. If you run into any problems executing this step, just shout out in the chat and we'll be able to assist with you, probably with DMs. But nothing should go wrong with this first step. This is just going to be the very first step of getting your first deepfake up. In a minute or two, the first 2 cells would have finished generating, and you should be presented with a screen that looks like this. I haven't loaded mine right now because I'm doing this live and I have another copy open in the background. But basically how this interface should look like is over here, there'll be some sample pictures of people. I think one of them is Donald Trump, another is like Obama, and then there'll be like Shrek in the cartoons. But you also have the choice of uploading your own image. So you just click here and then it should come up with a pop-up to select your own image. You can either put your own face or you can just select one of the easy ones here. They're all just like famous celebrities. And at the bottom, there will be different videos. These videos, they're just of people talking. So I do recommend you to, for your first deepfake, to go with the first video. Yeah, so I guess for your first deepfake, I would recommend you to upload one of your own pictures and then select the first video. Leave everything in the settings box as default and hit the generate button. I'll give people a couple seconds to get that process up and running. Once you hit this generate button, like the dude described here, the generator and the discriminator will be working against each other to come up with your deepfake video. From my experimentation, it generally takes 3 to 5 minutes to generate your first deepfake, which is why I have prepared one. Oh crap. Which is why I have prepared my own deepfake in the background already before this lab started. So, because I know this will take 5 minutes and it's just going to be 5 minutes of us sitting around. And here we go. I hope you guys enjoy. One thing that we think would be really awesome if for everyone who is attending today, if you could generate this dame video and then email it to us at youradsc.com, and then we'll make a compilation of like a 4x4 or 5x5 of everyone singing the same song at the same time. We're likely going to be posting that to our LinkedIn, maybe Facebook. Doesn't necessarily have to be your own face. It can be just the first deepfake that you have made. But try not to use your friend's face without their permission. You can make it with their photo and then DM it to them. But like I said before, please do not try to post your deepfakes anywhere without at least getting permission from your friend. So once you're done with this, you can download this. Alternatively, you can convert it to a higher resolution. I haven't done that myself, actually. I'm not sure how long that's going to take, but I was able to just hit download on this. Download. Okay, I think my runtime's not connected, so it's not going to let me download. But once you're done with this and you want to make more deepfakes, all you got to do is to hit the back button. That's going to take you back to this screen. From then on, I guess it's just whatever your imagination comes up with, you can make a deepfake of. The only requirement is that the video that you're giving it, which you can upload, is of someone's headshot about this wide and this long, of them talking. And the image needs to be like a headshot image with the face around the center. I think we'll be splitting everyone into the breakout rooms now, so everyone can have a try, make 1 or 2 of these deepfakes. If you guys run into any problems, our executives will be wandering around and helping you out. I think within 5 or 10 minutes, everyone should have a couple of deepfakes made, and we'll return back into the main room for the second part. So Michelle, could you throw us all into different breakout rooms?
Yeah, sure. I will open all breakout room now, and you guys can assign yourself to the breakout room if you want. We have 7 breakout rooms.
How do I do that? All right, I'll be joining the breakout rooms. See you guys.
Do let me know if you guys have any trouble of joining breakout room, because I can assign you manually.
So are you guys okay? Everything all right? Good. Everything's okay? Good, good.
Can I help at the moment? Are you guys in your own notebook one? Hey guys, could you join in the breakout room that I have assigned you? So I feel of you are assigned in breakout room already. If you can just click to the breakout room button, you will see the room that you were invited to. And see.
I assume everyone who came back into the main room were all happy with their first deepfakes. If you could upload it into a Google Drive public link and email us at youradsc.com, that would be really awesome. I think we'd like to make like a compilation of your first deepfakes. So I'll just type that again in the chat. Feel free to just unmute and talk to me, by the way. I feel super weird. I'm the only person that has been talking this whole time.
Hey, Yufei.
Yo, Winston, what's up? Did you make... Yo, send us your deepfake, eh?
All right.
We're aiming to produce sort of like a compilation by the end of this session. We have a total of 4 notebooks to get through today. So once we clear everyone out of the breakout rooms, I'll be passing the talk over to Hajar, which will be taking us over AI painters and neural style transfer. How can I see people in breakout rooms? Oh, I see. There's still a lot of people in breakout rooms, it looks like. No? Can I broadcast or miss?
already, I think for full notebook, which usually take around 3 to 4 with the copy, grade that I send you, it will take way longer time.
Michelle, it's really hard to hear you.
That's great.
Your voice is cutting. I'm not sure if it's my net. Oh, Ines says she has to go now. Yeah, that'll be fine. We will have a recording up. So if you signed up for this event, we'll be sending you a private YouTube link, and you'll be able to just follow all the instructions in your own time if you guys wanted to make your own deepfakes. I kind of want to hop into room 4 for a little bit. It seems like a lot of people from there are still just hanging out. I'm going to go check up on what's happening there so we can move on with the next part. Let's go to room 4.
If you want to prepare for the next part of the session, go copy the second notebook in that link. So it's called 2 NST Van Gogh, and look online for a photo that you want painted in the Van Gogh style.
Hey, Hajar, I can't see your share screen. Am I the only one?
Are we starting? Is everyone back?
Yeah, I think that's everyone back now.
Okay, yeah. I was just telling people to start preparing, but yes, I can start.
Yeah.
All right, thank you, Ife. We are now onto the actual cool part of the workshop. So we'll become all master artists by the end of this workshop, but without actually being able to draw, because I can't. We'll use computers to do that for us. So neural style transfer is just a fancy name for saying we will have a reference image and a content image, and we want the content image to be in the style of the reference image. So you see here, we have a photo of a black hole that looks really cool. And I was like, I would love to see this painted in the Van Gogh style. So I got the Van Gogh's Starry Night, which I really like how it looks, and just, combine both. Combine the style of one and the content of the other to make this cool new photo. So how this works is Ife already sort of explained a little bit in the video about convolutional neural networks, which are networks that are just really good at dealing with images. the way they work is they have multiple layers, and each layer takes a segment. So the first layer takes a segment of the main photo and processes it. And then the second layer takes a segment of that segment to process it, and so on. So the first layer sort of gets big chunks. The last layer has really small details. So, yeah, so this is sort of how you can visualize the segmentation. And this is sort of a very basic overview of the details layer is on the right, and you can see it's barely seeing much. And then the middle one is some sort of in between, is seeing the full nose or the full eye. And then the overall layer can see the actual like entire face. So this is what a neural style transfer model would use. Instead of using the entirety of the convolutional neural network, it would just use the layer that can only see the detail. And it will use that to sort of copy these details from the reference image, which is the style, to the content image. So it keeps the face or the black hole image as is, because it did not change the overall image. It's just copying the little details, which is the brush strokes, for example. So this is sort of a quick visualization of how it works. Like you have the main image and you have the style, like the style image, the reference image. And what it's doing, it has a generator. Like it is a type of GANs, but it doesn't have really a discriminator because it doesn't need to. It is generating at every iteration, it is generating a new version of the original dog image in this case, that has a bit of detail from the style image. And then it compares it to the actual style image and sort of says, okay, is this actually like close, or should I go more? And it keeps doing that until the number of iterations you've told it to go. So I've done a bunch of different space photos in Van Gogh. I really like his strokes when it comes to space and blues and skies and stuff. So these are some of the stuff I produced using NSCs, which are really cool. You can do this with whatever photo you want. These are a bit more of auroras. So now, again, let's go to not here. Here. Copy this. It should say copy of to NSC Van Gogh. And if you want to use an image from the internet instead of the image I already put in there, just go to Google, click an image, and say copy image address, and then go to the copied version of your notebook and paste it here. So base image path and paste it instead of this link. This is how you'll be able to generate your own image that looks like Van Gogh instead of, yeah. Once you're done that, you would run this block and check that the image you put in is the one you want. And then you'll go run the next block. And then you would go here and run this block. If you want, there's two numbers you might want to change in this block. One is the number of iterations you want it to go on for. I put it currently at 100, which is just not a large number that's not too large and it's not going to take too much time. But you can make it more or less if you would like. And I've currently set it to show us an update at every 5 iterations. So if you see here, this is sort of my image after 5 iterations, and this after 10, and so on. And you can see it getting more and more like Van Gogh style. So this is the full 100 iterations. You might want it to run for more if you would like. But yeah, if you change that 5 number, you'll just see more or less of these steps. If you want to see more steps, make it to run every 1 iteration. Yeah, we'll go now to breakout rooms to see who wants to, like, you know, give this a go and have our own paintings. I do know that some people, I know my supervisor did this for his friend's birthday as a birthday gift, like his own portrait in his favorite painter's style, which was really cool. So you can do a lot of things with this, a lot of really cool things. So yeah, let's go to breakout rooms.
Hi guys, just so you know, you can click to the breakout room again to join the breakout room that you have been assigned to. I think you should have, yeah. And let me know if you have any trouble with going to a breakout room. Some of you here, are you have trouble with joining to the breakout room? Please let me know because I already assigned all you guys to the breakout room. So yeah. But feel free to stay and ask me any question if you have. In the meantime, when people are doing for themselves, this can take quite a while to train. I can show what it is in my part as well. Yeah, so this is our 20 iteration. So it will look like this. You can change the image on the photo from here, I believe. Yeah, so you can go to Google and get the image address from there. You can also choose from your own link as well, as long as this will have to be the image location. But yeah, so you will receive, you can see there's a difference between each of the 5 iteration. And this after 20 iteration look pretty close. If anyone want to share, feel free to. Hi, Emily. Welcome back. By the way, I also allow you guys to share the screen. So while we're waiting for people, if you want to share people, your artwork, feel free to.
Should we start sending people back if they're just waiting, if the only thing they're doing is just waiting for the iterations in the background?
I don't think that we can force people back. You can only,
I
yeah,
can send like an announcement.
yeah. Yeah, I think you can. Wait, are you typing the message already?
Yeah, I'm doing it.
Okay, sweet.
While people are joining back again, does anyone want to show us what their images look like so far?
I can. Oh, do I still have it? I didn't close it, all right? Well, no one's sharing, so I'm just gonna share. This is what I had. Bruh, it just looks like I'm tripping on acid. There's no trace of Van Gogh in this. I think, like you said, we do need to keep it at a higher iteration. So I think when we found this notebook, the iteration count was by default set at 400. But obviously, with the time constraint, we're doing this live. We can't possibly afford to let it run for 400. That's going to be multiple hours. And it's the same thing with the first notebook as well. That's why, like, you can kind of, it's really obvious that it's a deepfake. But rest assured, we do have a whole heap of resources, including ones that run for up to 10 hours that can generate realistic deepfakes for you. We'll introduce those as we progress with the rest of the workshop. I think I'm seeing everyone back from the breakout rooms. So I assume everyone's already like training their neural painter in the background. So it doesn't require any more input. So I guess I'll just move on with the third and fourth notebook before sending everyone off back again into breakout rooms for you to have a play. So the difference here is I'm gonna showcase what the notebooks do, but we won't be sending you into breakout rooms until the very end when we're done with my talk. This is to allow time for your neural painter to finish executing. Cool. So just like we did with the first two, I'll paste the link in the chat again. And this time we're making copies of the third notebook. So this one here is actually a human motion deepfake video, a human motion deepfake notebook. The setup here, once again, is quite simple, comparable to 1 and 2. All you have to do is to click this play cell on the first and second cells. Obviously, I think everyone's NST is still executing in the background. So when you press this button, it's going to tell you to terminate your NST session. So I ask you guys not to terminate that for now and just let it finish running. I have one up on my screen. I'll show you guys what to expect when it has finished executing. So when it comes time for your NST to finish, you can just go ahead with the third and fourth notebooks in the free time that we'll be letting you guys have after. So if I go to my other Chrome tab, this one? No, this one. I have another copy open that I have already preloaded. So prior to this workshop, I already loaded that up into my environment. This whole process, I would say, takes about 10 minutes. All you have to do, like I said, just press the play button. It might give you a couple of errors when it's downloading these packages, but for me, it doesn't really affect the performance of the model, so I kind of just ignored them. Once the first cell has done running, I think it should take 10 minutes. Just run on the second cell as well, and it creates sort of a interface that looks something like this. So quite intuitive to use, just like the first notebook that we have. At the bottom is where we select the driving video. At the top is where we select the source image. So it does come loaded with a heap of videos. I think most of these are like TikTok dances or something. I see a Fortnite dance over here. If you want to have a look at what these driving videos are, in the first cell, there's a link called assets. All you have to do is to paste this into your browser. It's going to download a zip with all the sample videos inside. I already have that downloaded, so I'll just open that up and show you guys what that looks like. So if I go to samples, references, I can see, let's just open one randomly. Yeah, like This is what it will look like. And the whole point of this deepfake algorithm is that instead of just focusing on the face, it is a whole body algorithm. So I'll show you guys something that I have made last night. I think I have it open here. Right, so all you have to do is upload a front standing photo and also a back standing photo, as well as just the background to the tool. And you should be able to make something like this.
我打一个，连5遍啊。打了5遍，1遍、2遍、3遍、4遍、5遍，这5遍要连死打。你看这个实战性要动步啊，实战性。 实战时间一定要动步，全身松好，用3维的还原镜，才能打出整劲，打出松果弹抖，闪电鞭。谢谢朋友们。
I hope you guys enjoyed that clip. And also I have one other that I have pre-made that I want to show you guys as well. So this one, in this clip, in the previous clip, he didn't actually turn around that much, but in this one, the person in the video actually turns around, and you can see that is using the image of my back, even when I'm turning around. So have a look out for when I turn around in this clip. Yep. And we know it looks quite crappy, but you know, this only takes 10 minutes to render, which I think does a really awesome job for how long we're spending on it, because most of the deepfakes that you see, like of those news channels of like Donald Trump reading out fake news or whatever, they can take hours on hours to render. So given the limited time frame that we have, I think this performs quite well. So just go over the instructions one more time. If you wanted to use yourself as a training target, you would upload your front, back, and background image using these buttons. Quite intuitive here. I think this one is me standing in the front. This one is me standing with my back face. And this one is me, just the background. So you could get a family member to help you take these images. When they're uploaded, you should be able to see them shown in this tab here. Your other alternative is to choose some images from the internet. So if you happen to find a person showing the front, back, and background, feel free to use those. If you're too lazy to find your own images, there are a number of presets that you can just choose here. Pretty much just what they claim to be. I think for most of these, it's only the front image. So when you turn around in the video, it's really freaky because it doesn't know what your back looks like. So it just puts your front on your back. So you got two faces. So I don't recommend these. I would recommend uploading your own photos when you got time. Once you're done uploading your source image, there's a number of options you can choose for the reference. So like I said, all of these MP4 files corresponds to the zip that we downloaded earlier. If you wanted to have a preview, you just go into samples, references, you see what each of these original clips look like. So this was the one that I think he's some kind of like martial arts or Tai Chi person in China, and he's demonstrating some of his techniques. But like I said, most of these are like Fortnite dances. I believe there was, I can't find the Fortnite one. Yeah, there's a number in here. The other alternative, if you don't want to use any of those in the zip file, you can even paste in a YouTube link, just specify what time and it starts and ends. But I guess there's a few restrictions. It can't just be any YouTube video. Like the algorithm needs to recognize that it is a person standing somewhat center, so it can pick up the body parts and then form it according to the model that you have uploaded. So it would be good if you could find a video where it's just one person facing the camera. I think otherwise it might look really weird. Can upload from your PC if you got a video of you dancing and you want to put your friend on it, for example, that's totally possible. And again, if you just have a link from the web somewhere, you can just paste that in here. So once that's all configured, all you have to do is to press this play button. And this one here, from my experience, can take anywhere from 10 to 15 minutes. So 10 to 15 minutes to load this interface, then another 10 minutes to produce the output. We won't send you back to the breakout rooms now, because before we let you guys go, we want to cover off the last notebook. So just opening up our fourth notebook over here. Once again, remember to make a copy in your drive. So the fourth notebook I'm showing off today is still using generative adversarial network. So this one is a pre-trained model that someone, I think a data scientist at BuzzFeed has made, that creates your own AI generated Pokemon. There is literally zero setup for this. You just press play on the first cell, and then you press play on the second cell. The only thing for you to configure, I guess, is how many images to fit in a row and how many rows to generate. Just to give you guys a preview, this is the ones that I have generated in the past. These Pokemons do not exist. The algorithm learned to make these Pokemons themselves. So yeah, this could be another area for you guys to look into if you guys are interested. One website that I came upon while I was, there are some other functions to allow endless generation of Pokemon. So if you don't want to leave a notebook just hanging and generating like while your computer is open, you can link up your Google Drive, hit a button, and it's just going to generate a bunch into your Google Drive for you to look at in like tomorrow when you wake up or something. That concludes the majority of the actual notebooks that we have to showcase, but I do want to talk a little bit about the further resource that's available in the final notebook. So if you scroll all the way to the bottom, if any four of the notebooks interested you, I've managed to find more resources. For example, ones that didn't get to showcase were real-time voice cloning, text to image, and advanced motion GAN. I think it's kind of like the human motion one, and also some advanced deepfakes. Like I mentioned before, they can sometimes take up to 10 hours to render, so do at your own pace. These are all just collections of other deep learning collab notebooks. Just all kinds of cool stuff that you can do with deep learning. Some blogs, if you were more interested in generative artificial networks, some of them have really good applications on how GANs could be used when it's past just deep faking. One resource that I really like to recommend to you guys is 2-minute papers. So what this YouTube channel does is they take scientific papers and they summarize it down to, well, they say 2 minutes, but really it's like 5 minutes. So for example, if I just click into a
2-minute papers with Dr. Caro,
and find out the latest research that NVIDIA is doing, which is basically you can do a stick figure painting and you can generate really at lightning speed, like so many iterations of whatever image that you wanted to paint. So I guess this summarizes the state of generative adversarial networks, and we think there's a lot of exciting things happening in this space. The last thing I wanted to show is probably this link. Remember at the start I said by the end of this workshop, we should be able to describe the tech behind deepfakes. So generative adversarial networks, if you remember, is the generator and discriminator, two brains fighting against each other to trick each other. And then eventually it learns the computerized way to produce the deepfake output. Create GAN synthetic media. After we let you off into the breakout rooms, you guys should be able to use any of the notebooks and as well as these collections of further resources to create your own GAN synthetic media. Crap, where did it go? Equipped with ideas to kick off your own GAN projects, what I'm going to cover next. Further resources, you'll find them at the end of the 4th notebook. So one thing that the person did over here, which is similar to the Pokemon generation, notebook, is you can select a type of Pokemon and you just go generate, and it just generates it on the fly. So why I kind of want to showcase this is relating to this point. So I think if you were to be really interested in GAN, like if you spend enough time figuring out the ins and outs, I think something like this could probably be created with not a lot of effort. It's something quite visual. When you're applying for jobs, this could easily be something that, you know, make you stand out from other applicants. So just putting that out on the table, maybe it's something for you to consider if you're graduating and heading into industry soon. I know that if I'm an employer and I see that one of my students like use generator adversarial networks to make something of their own passion, I'll be really impressed. I guess that concludes all of the planned talk that we have today. From now on, the plan is to just go into breakout rooms again. You guys have all the resources available to give this human motion deepfake as well as the Pokemon deepfake a try. There's no order. You can just even go back into the first notebook. And if you guys run into any problems, the execs will be around to help you out. Cool. I think that's all I gotta say for today. Hajar, you got anything more to add? No? In that case, Michelle, could I just get you to send people to the breakout rooms?
Actually, like they can join the breakout room by click to the breakout room because
Okay.
they already been assigned. So they can just join the breakout room that they
Sure.
have been assigned to.
Yeah, if you guys just want to have a play with any of the 4 notebooks, now would be the time to just head into a breakout room and create some deep fakes yourself.
Oh, if you might want to stop the recording now.
Stop share or stop the recording?
Recording because that's, yeah, because